Okay, we got 1.48 now for our video notes. Okay, so what we're dealing with is called algebraic proofs. So if you guys can remember from 1.3, we talked about using the properties of addition, multiplication, subtraction, division, those kinds of things. And we're going to apply them to this stuff right here. So you guys can see these lines that we have here. What we're basically going to be doing is writing down the process that is occurring on our left-hand side of the equation. Now, it can be lengthy, but it's good to know what is actually happening inside of an equation instead of just looking at the numbers, right? And why things are actually occurring the way that they are. We don't always show it, but it is good to understand it, okay? So, for reference, okay, a lot of what I'm going to be doing is going to be using this right here, this paper from 1.3. So I'm going to be naming properties here. If you need to pause or anything like that, understand that it's, probably going to be helpful in recognizing what kind of properties there are. Okay, remember, we can use these on our test and everything, but just for the sake of not flipping back and forth, I'll only be on this page for right now. Okay, so first thing that we have to do, we have to justify each step by stating which property was used. Now, the first one that we're dealing with. First, what is happening in this stage of the equation? Well, we're adding, okay? We're adding 7, okay? So, if we're looking at what our properties are, and what we have to understand that what we're doing here is going to have some form of addition involved, okay? So if I go back here, I'm going to make my way down. Is it the commutative property of addition? Well, we're not moving things around, I don't think. Could it possibly be the associative? I don't think so. It's the addition property of equality, right? What it's basically saying is we add the same number on both sides of the equation, we'll have an equal thing. As you can see here, we're adding 7 to both sides, right here, okay? So, I'm going to write addition property of equality. Now, you guys can do add, prop, equal if you want, but for right now, I'm going to write addition property of equality just so you guys know what I'm actually writing. Okay? So, what you guys are going to learn pretty quickly is that most of the time, after any property of equality, you're always going to have what is called a substitution rule. And what substitution means is that we're basically substituting 5 plus 7 for a 12. Okay? This substitutes for this. So this step is going to be substitution. So once we get into properties of equality, because every single time we solve an equation we're going to be using properties of equality, the following step is substitution every single time. Okay? So let's go to C. What is happening on both sides? Well, we're dividing by 2 on both sides. So we're equally dividing. So this is going to be the division property of equality. Okay? And here, like the last one, when we end on a property of equality, the next step is always substitution. Okay? And that's how we do it. Alright? Now this one's a little bit more complicated. Instead of 4 steps in solving it, we have 5 steps that we're going to be using to solve. So, for A, what we're going to start with. This is our starting equation. How do we get to here? Well, it's understanding that we are distributing R3. So this is our first step. It is called the distribution property. The distributive property, I should say. Oh my gosh, I can't spell. Distributive property. Distributive property, okay? All right, let's go on to the next one. What is happening here? Well, I'm adding 6 to both sides, so this is the addition property of equality. Then, remember, what follows the property of equality? Substitution. Next, what's happening here? Well, we're dividing both sides by 3. So, it's the division property of equality. And once again, if you guys don't want to write all of this down because you've already caught it, you can do div, prop, equal, or anything like that. As long as I can see what division, if that is division, and you understand as a prop of equality, that's what I want. Okay? Even I accidentally shorthanded that one. And what follows the property of equality? Substitution. So, let's go to our next one. Now this is a little bit different, but it's a very short problem. What is it actually doing? Here, I'm going to zoom in just so you guys can kind of see a little bit better what it looks like. We have 7 to the x equals 2,401. Okay? And what they're doing here is a little bit different. Remember, what does substitution mean? Substitution means that you're substituting something with equal value in. Okay? So, if we can remember from our earlier in our notes, we turned this number into something with a similar base of 7. So this has a base 7, and that's how we get 7 to the 4th power. Okay? So we substitute 2,401 for 7 to the 4th power. So this step is substitution. And then, what are we going to be using? Now, if you guys reference, there's only one exponent property on the other side. It is called the equality property for exponents. Okay? So, exponent ones are pretty simple. Substitution and equality property for exponents. Okay? Just like that. Oh, did you guys see it? Or did I not even get it in? Yeah, so substitution, equality property for exponents. Okay? Might have to record that back and see. Okay, zoom out a little bit more. So, click here, make sure we're getting focused. Okay. So, next one. Here's what we want to do. Okay. First thing that I need to do is see what's happening on both sides of my equation. What am I doing? I'm subtracting x on both sides of my equation. So what is that step? Well, it's the subtraction property of equality. Okay. Then, what always follows the property of equality? Substitution. That sounded weird. Substitution, okay? What is our next thing that we need to do? Okay, well, we're looking here. What's happening in the problem? Well, we're subtracting 8 from both sides. So that's got to be, again, subtraction property of equality. Okay, here's our next one. Remember, what follows the property of equality always? Substitution. Pop substitution in there. Next one, dividing on both sides. What's that? It's the division property of equality. And then, what follows the property of equality? Substitution. Okay, just like that. So, now, this is where it kind of gets a little bit different, right? There will be times when you must solve the equation and justify your steps using properties. So here's what I would do if I were you. Solve first. I would always solve first and then justify your steps afterwards. Okay? Solve first is my hint. So, let's do what we think we need to do first. Okay? So, for me, I want to get my variable alone. We understand that our first move should probably be to subtract our 5 off of it. So let me write this down again, and I'm going to subtract that 5 away from my x. Okay, and the 5's cancel for me, and that should leave me with negative 2/3 x equals 1 minus 5, which is a negative 4. Okay, so can you guys if you guys can remember, there is something that we can do without fractions. What is it called? If I pull it over here. Okay. It is called, where do we put it? The multiplicative inverse. Okay. If you multiply by the reciprocal or a flipped over fraction, what happens? It changes into a 1. So, what is, if I'm thinking about it, what is the flipped over version of 2/3? Well, that's just negative 3 over 2. I'm going to times both sides by it. Now, for those of you guys that have a little bit harder time with fraction, that's okay. What I want you to do, go into your calculator and press alpha. Oh my gosh, turn down that white balance, would you? Alpha y equals. Hit your numerator denominator button. Okay. Now, those fractions do cancel out. If you guys have are wondering why, okay, I will show you anyways, just so you can see it. Obviously, it turns into 1, okay, and then we want to do negative 4, our other number over here, times that negative 3 over 3 halves, times alpha y equals numerator denominator negative 3 over 2, and that will give us 6. So we replace it, and we get x equals 6. Okay, now need you go in there, and now we need to talk about what steps we did. So the first one, we subtracted 5 on both sides of our equation. That is the subtraction property of equality. Then, what always follows the property of equality? Substitution. Then, what did we do? We multiplied. Now, we did multiply both sides by a number. Okay. I'm going to say that it's called the multiplication property of equality. Every time we have a property of equality, we always follow that up with substitution. Got it? All right, last couple, and then we should be done with this section of notes. Okay? So, we need to go back to our previous section where we talked a little bit about how to find exponents. So, you guys can recall, what base am I working with here? Well, I'm working with base 3, because that's a 3 over there. Okay, and we need to be able to get that all the way so that 2187 and 3 have the same base. So what do? I get out my calculator and I start typing. Okay, so I'm looking here. I need to start going 3 to the 1 is my first one, and then just keep going 3 to the 2, 3 to the 3. I'm getting closer. 3 to the 4, 3 to the 5, 3 to the 6. We're getting almost there. 3 to the 7. Okay. So now we have our 2187. It matches. So we're going to rewrite this as 3 to the x equals 3 to the 7. Right? Then, what is this? What are we going to do next? Remember, if they have the same base, then the exponents are the same. So this has got to be x equals 7. Okay? Now, I'm going to move the calculator out of here so we can kind of get a refocus on it. Okay, so if we're doing this, now let's talk about what happened. It's very similar, I would say, to something that we saw on number 3 on the other side of our packet. You guys can remember, what did we do? We called this substitution, right? So we're going to do the same thing here. We're going to write in substitution on our first one. Now what about our second? Well, what kind of property did we use? Well, we used the property of, what do we got? Well, no, I shouldn't say it's a property. It's the equality property of exponents. Okay, that is what we're looking at. Okay, I hope this video was helpful. If you guys need anything else, make sure to email your teachers or talk to them in class.